All right, so we're on to my favorite section of the class that we have. This is kind of where we begin to expand our knowledge of algebra and the universe a little bit more. So section 7.7 is the topic of what's called complex numbers. Now, don't let complex scare you. It doesn't mean they're hard to work with. You have just about all the tools to work with complex numbers. It just is speaking to the fact that complex numbers are two-dimensional numbers. So where does this come from? Well, this comes from some fun mathematician, probably been out drinking on a Friday night, considered this equation right here, x squared plus 1 equals 0. Now, the only way we have solved quadratic equations in here is by factoring. And just as a little aside, when you take college algebra and we spend a whole bunch of time graphing quadratic equations and parabolas, what you're going to see is that this is the equation of a parabola that's pointing upward and goes through the y-axis at the point 1. So what we would want to know is, when is this equal to 0? Well, if you look at the graph, it's never equal to 0. It never goes through the x-axis. But that does not stop our fun, drunk mathematician from making something up. And he says, okay, this is what we're going to do. We are going to subtract 1 from both sides of this, okay, like we would ordinarily do. And we get the new equation, x squared is equal to -1. And then, just because mathematicians a lot of times think out of the box, and that's why we have new and novel things, our friend the mathematician said, okay, now what I'm going to do is I'm going to take the square root of both sides of this, just like we would do if it was a whole number. And so when we take the square root of both sides of this, again, for the time being, I'm going to ignore that we have both a positive and a negative answer, and we get that x is equal to the square root of -1. And so, undeterred, our mathematician says, you know what? I'm just going to define that to be something. And so that became the solution to the equation x squared plus 1 equals 0, became what's called the imaginary unit. And so this is the only new piece of information really in this section, the definition of the imaginary unit. The imaginary unit is I, lowercase I always, and is defined as follows. I is the solution to this equation that we just talked about. I is the square root of -1. And the corollary of that is, if I square both sides of this, if I square I squared the square root of -1, I get I squared equals -1. So this is super important. Okay? This is good for your future in this class and the next class. If any of you are going to be engineers, if that's why you're going through the STEM side of things, I pops up all over the place. It's amazing how this thing called the imaginary unit has so much real world application. Okay, my daughter's an electrical engineering major. She's about to graduate, and in every class, it deals with eyes and how an eye interacts with trigonometric functions in really funky and crazy ways. So you have a lot of fun ahead of you. We are just going to talk about the super basics of the imaginary unit here, enough so that we can solve quadratic equations. That is our goal in this class. That is handy information. It's a definition. It got made up. Okay, and now we're going to take this definition and we're going to use it. So the first thing we're going to do is we're going to simplify radicals that have a negative under them. If you remember, a long ago in a class far away, I said, hey, this was my example, square root of -25. And I said, hey, let's just call that undefined. Well, now we're going to define it. Okay, so on the test, when I put something like that, you're going to give me an answer. So here we go. This is what you're going to do. You're going to say, okay, I'm going to factor that into things I can take the square root of. I'm going to factor the square root of -25 into a -1 times a 25. Now, again, you don't have to write all this down. I'm just going to do this for the first couple because we're just learning this. My assumption is some of you've seen it, but probably a lot of you haven't seen this. So I'm going to use the product rule of radicals, and I've got the square root of -1 times the square root of 25. Okay. Well, what's the square root of 25? 5. What's the square root of -1? That's been defined for us. So I write that as I. And there's your answer, 5i. We have now defined it. Okay, square root of a negative number is now defined in terms of imaginary unit. So here we go. I'm just going to have you do some of these. So do example 1. That was going to be my example, but I had fun with the square root of -25. So do the square root of -75. So once again, I'm just going to separate this into things I can take the square root of. Okay, if you had trouble with this one, don't worry, we've got a couple more. Okay, so the square root of negative 75. First thing I'm going to do is I'm going to break this apart. So the negative I'm going to call negative 1. And how can I break 75 apart? What's its perfect square factor? Okay, 25 times 3. One more time, I'm going to write this with the product rule of radicals. Then I'm going to stop doing this step. So I'm going to, product rule of radicals says I can give each of these their own radical. And now here we go. Square root of 25 again is 5. Square root of negative 1 is, it's defined to be I. And then the square root of 3 stays the square root of 3. Now, when I write this down, I will always write the I in front of the radical. Most textbooks do that. It is not wrong to write square root of 3i, but just be super careful that you're not writing something. The reason most people write it in front is because, you know, sometimes we're lazy with our radicals and we might write the roof of it longer. The square root of I means something, okay, mathematically, okay, and we're not going to get into that. So you might accidentally be writing something that you don't mean to. So what I would encourage you to do is, if you have this, I would write the I in front of the square root just to be safe. Okay, so that's what I will continue to do. So do exercise 1 right next door, please. So this is very similar to the one that I just did, the square root of negative 25 that I did on spur of the moment. So this is the square root of negative 1 times 49. And so I'm not going to write out the product rule of radicals. I'm just going to skip to the punchline. The square root of negative 1, that is defined to be I. And then the 49, the square root of 49 is 7. I always put whole numbers in front like it's a coefficient. So 7i is our answer. Do exercise 2, please. Simplify, write in terms of the imaginary unit. That's what we are doing. Write square root of negative 7. All right, so once again, this problem, don't make this more complicated. It's just going to be the square root of negative 1 times 7. 7 can't be split apart, it does not have a perfect square factor. So all this is I've got the square root of negative 1, which we have defined to be I, and then that square root of 7 stays square root of 7. That's it. That's all you've got to do. One more of these, the one right next door, the square root of negative 54. Please do that problem. right? So I'm going to take this. First thing is I'm going to break this up. So the negative is -1 times. What's the perfect square factor of 54? Okay, it's 9 times 6. Fantastic. So here we go. We will take the square root of the things we can, and we'll leave under the radical the things we can't. So here we go. The square root of -1 is defined to be I. Great. The square root of 9 is 3. And then the square root of 6, I'm just going to leave square root of 6. All right, so we're going to do the final 3 problems on this page, and then I'm going to define for you what a complex number is, and that's where we are going to leave ourselves for the day, and we'll pick up in our next class right after that definition. So when I have to multiply my radicals, okay, and I've got negatives under there, we cannot, unfortunately, just say, oh, this is the square root of -5 times -6 or 30. It's not quite that simple. Before you can do the multiplying, you have to write these numbers in terms of the imaginary unit. Okay, so again, once you get good at this, I know you don't have to write this step down. So if you can just skip this step, but I'm going to write it just for anybody who's not there yet. The square root of -5 is -1 times 5. The square root of -6 is -1 times 6. So this is I square root of 5. And then this is I squared of 6. Everybody tracking with me? Did I go too fast there? We all right? Just using that definition. Now we can multiply. Okay, here goes. The stuff outside the radical, the i's. What's I times I? I squared, just like a variable, just like an x. No different. Square root of 5, square root of 6. Square root of 30. Now there's one more step. Because remember the corollary in our definition, we saw that I was defined to be the square root of -1. So what is I squared equal to? Just -1. So down here, this I squared, okay, this I squared becomes -1. So this is -1 or just negative square root of 30 is the answer. So those imaginary units matter. So why don't you do, it doesn't matter the order we do these in. Go ahead and do exercise 4, the next one right to the So once again, I've got to write these things in terms of the imaginary unit. So the square root of -4 is -1 times 4. The square root of -16 is -1 times 16. The only difference in this problem and the previous one is I picked numbers you could take the square root of on this one. So the first one is I've got square root of 4 is 2 times I. And then the square root of 16 is 4 times I. So that's what that becomes. So I'm going to multiply those two things together. 2 times 4 is 8. I times I is I squared. And then once again, just repeat this because repeating helps you remember. What's I squared defined to be? -1. So that becomes -8 is the answer to that problem. All right, one more problem for the day, and then I'm going to define what complex number is, and then we will stop. So you're almost free of me. So once again, this is very similar to the example number 2. The square root of negative 7 is negative 1 times 7. The square root of negative 11 is negative 1 times 11. So that is I square root of 7 times I square root of 11. The I times I is equal to I squared times the square root of 77, which can't be simplified. And then I squared is simply defined to be negative 1. So that's negative square root of 77. So now that we have the idea of what the imaginary unit is and doing a little bit of it, let me just tell you one last thing. We're going to take our imaginary units and we're going to create a new set of numbers. Your whole algebra lives up till now in intermediate algebra, we've only used real numbers. Now we're going to expand the set. So if A and B are any real numbers, the numbers you're used to using, then if we format them like this, any number of the form A plus BI is called a complex number. And it's called complex because it's got 2 dimensions, not because it's hard to work with. The number A is the real part and the number BI is the imaginary part. Okay, so any real number, A, okay, that's a real number. BI, anything of the format B or a number in front of I, that's an imaginary number. I can't spell and write, sorry. Our book will actually call it a pure imaginary number. I'm just going to call it imaginary number. And then when you link them, when you link them together and you put them A plus BI, I will call that a complex number. Our book calls that a non-real complex number. There's no, we don't need to be that technical, but just want to make clear to you, all of these numbers, all of them are examples of complex numbers. The real numbers that you've used up till now are just complex numbers that are missing the imaginary part. Imaginary numbers are just complex numbers missing the real part. And then the A plus BI, that's the traditional form, what you would normally think of with a complex number.